Poisson distribution in random variables. The Poisson distribution plays a crucial role in various applications, which include modeling the number of events occurring in a fixed interval of time or space. This study explores the Poisson distribution in random variables, its properties, and its applications. What is the Poisson distribution? The Poisson distribution is a discrete probability distribution that expresses the probability of a given number of events occurring within a specified interval of time or space. It is particularly useful in situations where events occur independently of one another and at a constant average rate. Mathematical definition. The probability mass function PMF of the Poisson distribution is defined as the probability mass function PMF of the Poisson distribution. Key properties of the Poisson distribution. Mean and variance. In a Poisson distribution, the mean, mu, and variance, sigma squared, are both equal to lambda. This property simplifies many calculations and interpretations. Memorylessness. The Poisson distribution does not have the memoryless property, however, it is often used in conjunction with the exponential distribution, which does. Independence. Events modeled by the Poisson distribution are independent. The occurrence of one event does not affect the probability of another event occurring. Applications of Poisson distribution in random variables. The Poisson distribution is widely used across various fields, including queuing theory, modeling the number of customers arriving at a service point within a given time frame. Telecommunications, analyzing the number of phone calls received at a call center during peak hours. Biology, studying the occurrence of rare mutations in a population over a set period. Example, call center analysis. Imagine a call center that receives an average of 10 calls per hour. To determine the probability of receiving exactly 15 calls in a given hour, we can use the Poisson distribution formula. Calculating this gives us the probability of receiving exactly 15 calls in 1 hour. Understanding the level of significance. In statistical hypothesis testing, the level of significance is a critical concept that indicates the threshold at which we reject the null hypothesis. It is denoted by alpha, and commonly set at 0.05 or 0.01. Importance of level of significance. The level of significance helps determine the probability of making a type 1 error, rejecting a true null hypothesis. When using the Poisson distribution in hypothesis testing, it is essential to calculate the p-value and compare it to the significance level to make informed decisions. Example, testing call center performance. Let's say we want to test whether the call center's average call rate has changed from 10 calls per hour. We collected data over 1 hour and found that we received 15 calls. We can set our significance level at alpha equals 0.05 and use the Poisson distribution to calculate the p-value for observing 15 or more calls. If the p-value is less than 0.05, we reject the null hypothesis and conclude that the call rate has indeed changed. The Poisson distribution in random variables is an indispensable tool in statistical analysis, providing insights into the occurrence of events over time or space. Understanding its properties, applications, and the level of significance enhances our ability to make informed decisions based on data. For further reading and deeper insights, consider exploring the following scholarly sources. Introduction to Probability and Statistics. Statistical Inference. Probability and Statistics. By mastering the Poisson distribution and its applications, learners can significantly enhance their statistical skills and analytical abilities.